Picture this. You're traveling at the speed of light for billions of years, racing past galaxies, through cosmic voids, pushing toward the ultimate boundary. What would you find at the edge of everything? A wall? Empty space? Or something so bizarre that our physics equations literally stop working? Today, we're venturing to the cosmic horizon, the place where reality itself seems to break down. What we've discovered there in 2025 is rewriting everything we thought we knew about space, time, and existence itself. Here's what's absolutely mind-bending. The universe doesn't have an edge like a table or a cliff. No. Instead, it has something far stranger. A horizon beyond which the laws of physics as we know them completely fall apart. Think about standing on Earth and looking at the horizon. You know, there's more planet beyond what you can see, right? But the universe's edge? It isn't like that. Not at all. When we look 13.8 billion light-years away, we're not just looking across space. We're looking back in time to the moment of the Big Bang itself. And here's where things get weird. The observable universe, everything we can possibly see, is about 93 billion light-years across. Wait, how can that be if the universe is only 13.8 billion years old? Shouldn't it be 27.6 billion light-years at most? This paradox reveals our first reality break. Space itself is expanding, and it's been stretching while light travels toward us. Imagine you're walking on a treadmill that's speeding up. You might be walking forward, but the ground beneath you is pulling you back even faster. That's what's happening to light from distant galaxies. But it gets stranger. Beyond about 46.5 billion light-years, the cosmic event horizon, space is expanding away from us faster than the speed of light. Those regions? They're forever unreachable, causally disconnected from us for all eternity. The light from there will never, ever reach Earth, no matter how long we wait. Let me blow your mind with what astronomers discovered just this year. The James Webb Space Telescope and new data from the Atacama Cosmology Telescope have revealed galaxies that shouldn't exist. Massive, mature galaxies from when the universe was supposedly just a baby. These galaxies are sitting right at the edge of our observable universe, and they're breaking our models of cosmic evolution. How did they form so quickly? Why are they so massive? It's like finding a full-grown oak tree in a nursery that was planted yesterday. But wait, there's more evidence that reality gets seriously weird at the edge. The cosmic microwave. Background. That's the afterglow of the Big Bang, shows us the universe when it was only 380,000 years old. And here's the thing that keeps physicists up at night. It's almost perfectly uniform in temperature, varying by only 1 part in 100,000. How did regions on opposite sides of the universe, separated by distances light couldn't have traveled, end up at exactly the same temperature? It's like two people on opposite sides of Earth, with no way to communicate, deciding to wear the exact same outfit on the same day. This is called the horizon problem, and it suggests something profound happened in the universe's first fraction of a second. Enter cosmic inflation, a period where the universe expanded faster than light, much faster, increasing in size by a factor of at least 10 to the 26th power in less than 10 to the negative 32 seconds. This would explain the uniformity, but it also means that what we call the observable universe is just a tiny, tiny fraction of what's really out there. We're like bacteria in a droplet of ocean water. thinking we've seen the whole sea. The evidence gets even more compelling when we measure the universe's geometry using the cosmic microwave background. We find it's flat to within 0.4% margin of error. A flat universe suggests it's infinite. No edge, no boundary, just endless space in all directions. But if it's infinite, that leads to some absolutely wild implications. In an infinite universe, every possible arrangement of particles must occur somewhere. That means there's another you, reading these exact words, an infinite number of times. There's a version where you're wearing a different shirt, where you made different life choices, where history unfolded differently. Now here's where theoretical physics goes completely off the rails. String theory and its modern evolution, M-theory, suggest our universe might be a three-dimensional brain floating in higher dimensional space. The edge of our universe might not be an edge at all, but a boundary where our dimensions meet. Others. Imagine living your whole life on a sheet of paper, thinking that's all there is, while that paper is just floating in a three-dimensional room. Recent calculations from 2025 suggest these extra dimensions might be detectable through gravitational wave observations. LIGO and Virgo have picked up anomalies that don't quite fit standard models. Could these be echoes from beyond our dimensional boundary? But here's the theory that really breaks your brain: eternal inflation. This suggests our Big Bang wasn't unique. Instead, the universe is constantly spawning new universes through quantum fluctuations, like bubbles in an infinite champagne bottle. Each bubble is a universe with potentially different laws of physics. Our observable universe would just be one tiny bubble, and its edge would be where it meets the eternally inflating space between bubbles. Stanford physicists just published calculations showing this multiverse isn't just possible. It might be inevitable given what we know about quantum mechanics and inflation. What if dark energy, that mysterious force accelerating the universe's expansion, is actually evidence of this larger structure? The 2025 Dark Energy Spectroscopic Instrument data shows dark energy might not be constant. It could be evolving, getting stronger over time. If this continues, we're headed for the Big Rip, where eventually every atom will be torn apart. But some theorists suggest this isn't destruction, it's transformation. Our universe's edge would expand until it tears, possibly birthing new universes from the quantum foam left behind. There's another possibility that's equally mind-bending. What if the universe is actually curved in a way we can't detect yet? If it curves back on itself in 4 dimensions, you could travel in one direction and eventually return to where you started, like walking around Earth. The edge would be everywhere and nowhere. Every point would be both center and boundary. Recent observations of galaxy clustering patterns hint at large-scale structures that shouldn't exist in a perfectly flat universe. The Boss Great Wall, stretching over 1 billion light-years, might be telling us something profound about the universe's true shape. Here's what really scrambles our understanding. Quantum mechanics suggests the edge of the observable. Universe might not have definite properties until we observe it. The act of looking might literally create the reality we see. This isn't mystical nonsense. It's based on the delayed choice quantum eraser experiments, now scaled up to cosmic proportions. When we observe distant quasars, we might be retroactively determining their quantum states from billions of years ago. The edge of the universe could be in a superposition of states, neither existing nor not existing until consciousness observes it. If any of this is true, the implications are staggering. We might develop technology to communicate with parallel universes, punch holes through dimensional boundaries, or even escape the heat death of our universe by jumping to younger ones. The 2025 breakthrough in quantum computing has already shown we can exploit quantum superposition in ways we never imagined. IBM's latest quantum processor just demonstrated what might be interdimensional information leakage. Qubits maintaining coherence far longer than they should, as if drawing stability from somewhere else. Understanding the universe's edge could unlock the ultimate questions. Why does anything exist at all? Are the laws of physics inevitable or arbitrary? Is consciousness fundamental to reality? The answers might lie in those regions where space-time itself breaks down, where the familiar becomes alien, where mathematics meets metaphysics. The European Space Agency's upcoming LISA mission will detect gravitational waves from the early universe, possibly revealing echoes from before the Big Bang or signatures of colliding universes. As we push our instruments further, peering deeper into space and time, we're not just exploring the universe, we're discovering that reality itself is far stranger than we ever dared imagine. The edge isn't a place. It's a concept that challenges everything we thought we knew about existence. Every new discovery doesn't answer questions. It reveals we've been asking the wrong questions all along. What do you think lies at the universe's edge? Is it an actual boundary, a transition to something else, or just the limit of what consciousness can perceive? Drop your wildest theories in the comments below. Next week, we're diving into something equally mind-blowing: the discovery of time crystals and how they might let us build perpetual motion machines that actually work. Make sure you're subscribed and hit that notification bell. Until then, keep looking up and questioning everything, because the universe is far weirder than we can possibly imagine.